Welcome to Kanerika's podcast, The Digital Shift. Let's start with a staggering reality. Every single day, Spotify processes over 600 billion events just to personalize the playlists you listen to.
Yeah, that number is just, it's almost hard to wrap your head around, honestly.
Right, like think about the sheer scale of that for a second. Every single time you skip a track, every time you pause, every volume adjustment you make, or even when you actually let a song play all the way through to the end.
Which is rare for some of us, but yeah.
Exactly. That is 600 billion distinct data points constantly flowing, organizing, and, calculating what song you actually want to hear next.
And it does it instantly.
Instantly. And here's the crucial takeaway for our deep dive today. That level of seamless, real-time data movement, it isn't magic. It's data engineering.
It's absolute precision architecture. I mean, when
Yeah.
you really look under the hood, moving that volume of information without entire systems crashing or, without cloud compute costs completely spiraling out of control, it requires an incredibly robust foundation.
Because you're basically capturing human behavior in real time.
Exactly. You're capturing it and feeding it into an algorithm in milliseconds. It's not just storing data, it's moving it with purpose.
Which is exactly our mission for this discussion. We're exploring the massive impact of data engineering, specifically how it turns all this raw, unmanageable digital chaos into actual measurable business value.
Because right now, literally every company on the planet is obsessed with data.
Oh, completely obsessed. But very few are actually structuring it in a way that makes it useful.
To frame just how critical this has become, we really have to look at the market's explosive growth. I mean, the global data engineering market is rocketing from roughly $95 billion in 2024 to an estimated $168 billion by 2029.
Wait, 168 billion? That is a massive jump in just 5 years.
Yeah, we're looking at an almost 12% compound annual growth rate. And, that isn't just incremental IT spending. That's a fundamental shift in how global business operates.
Because companies are finally realizing that their data is basically useless if it's just trapped in a silo somewhere.
Precisely. Having data and being able to actually use data are two entirely different things.
That's an astonishing amount of capital pouring into one single discipline. So let's unpack this a bit. With all this money flooding the space, what exactly is the engine behind these insights?
Well, that's where we get into the definitions.
Because people toss around terms like data science and data engineering interchangeably all the time, but they're very different beasts, right?
Oh, very different. I mean, at its core, data engineering is the discipline of designing and maintaining the systems that collect, process, and deliver data reliably at scale.
Okay, so how do we break that down practically?
We generally break the core functions into four main pillars. First, you have data collection. This is pulling raw information from your CRM, your financial databases, various APIs, external applications, you name it.
Just gathering the raw material from everywhere.
All right. And then second is integration, which is the incredibly complex task of combining all that disparate data into a single, consistent system.
Let me jump in there because I think transformation, which is your third pillar, is where a lot of businesses actually hit a wall.
Oh, absolutely. It's the bottleneck for most companies.
Give us a sense of why transformation is so notoriously difficult. Like, what does that actually look like on the ground?
Well, it's difficult because raw data is incredibly messy. Transformation means cleaning, formatting, and standardizing the data so it actually makes logical sense to a machine.
So it's not just moving it, it's translating it.
Exactly.
Yeah.
Imagine you have a European CRM system, right? And it records dates as day, month, year, but your American payment gateway records those exact same transactions as month, day, year.
Oh, I see where this is going.
Yeah, if you don't build a transformation rule to force those two systems to agree, your financial algorithm is going to miscalculate your quarterly revenue by millions of dollars. It'll think a transaction from October 5th actually happened on May 10th.
That's a perfect example. A tiny formatting difference that totally wrecks the financial model.
And it happens all the time.
And the fourth pillar, pipeline automation, is basically making sure that date translation happens on its own, right? Like instantly, millions of times a day, without a human having to manually fix an Excel sheet.
Precisely. We call those ETL or ELT processes: extract, transform, and load. It's about building automated workflows so this entire life cycle happens in real time, totally error-free.
Here's how I like to visualize the difference between the engineer and the scientist. Think of data engineers as the master architects and builders of a high-speed rail network.
Okay, I like this.
Right. They lay the physical tracks, they bore the tunnels through solid mountain, they engineer the complex signaling systems, and they basically ensure a massive train can travel at 300 miles per hour without derailing.
Which is a huge undertaking.
Exactly. Data scientists, on the other hand, are the conductors driving that train. They decide the best route based on the schedule, they analyze the passenger data, and they deliver the final value.
That's a great way to look at it. Because the scientists simply can't do their job if the tracks haven't been laid first.
But I have to push back here for a second. Doesn't the modern cloud just do all of this automatically now?
Ah, the cloud myth.
Right, because if a business signs up for AWS or Microsoft Azure, isn't the infrastructure just waiting for them? I mean, you pay for the storage, you upload your data, and boom, you're a data-driven company.
That is a very common and frankly a very dangerous misconception.
Really? Dangerous how?
Well, the cloud providers give you the land and the raw materials. They sell you the compute power and the infinite storage space. But raw data, just dumped into a cloud environment, is entirely useless without structure.
So it's not the magic bullet everyone thinks it is.
Not at all. It's not a data lake at that point. It's a digital landfill. You still absolutely need data engineers to build the pipelines, design the architecture, and manage constant schema changes as your business actually evolves.
A digital landfill. That's a great phrase. Because if you just dump unstructured data into the cloud, you're not just wasting storage, you're creating a massive liability.
Or a huge liability.
If you try to run an AI query on a digital landfill, the compute costs alone to search through all that garbage will basically bankrupt you.
Exactly. The cloud doesn't automatically govern your data or guarantee compliance. It just holds it, which is why internal teams are struggling so much right now.
So we've established that the cloud isn't a magic wand and that building these pipelines is incredibly complex. Why are large, well-resourced businesses still struggling to do this in-house?
It's a resource allocation issue, mostly.
What's driving them to outsource these highly specific services instead of just hiring more people?
Businesses are looking to specialized partners for a few highly strategic reasons. First, internal data science teams generally lack heavy infrastructure skills.
Because they're scientists, not builders.
Right. You pay top dollar for a data scientist, so they can build predictive models and analyze market trends, not so they can manage server loads and troubleshoot broken extraction pipelines.
If you force a data scientist to do plumbing work, they're going to quit.
In a heartbeat. Second, there's the massive issue of technical debt.
Right, the classic startup trap. You build a scrappy pipeline that works great for your first 1,000 customers, but when you scale to 100,000, the whole thing just snaps under the pressure.
Exactly. Bad data architecture built during a company's early growth phase will inevitably break at enterprise scale. And fixing a poorly designed data warehouse mid-flight while the business is actually running, it costs an absolute fortune and disrupts daily operations.
It's like trying to change the engine on an airplane while you're at 30,000 feet.
Exactly. It is far more cost-effective to bring in specialists who can architect it correctly the first time. And finally, we have to talk about compliance frameworks like GDPR and IPA.
Oh, the regulatory side. It sounds like you're saying GDPR isn't actually a legal headache, it's an architectural one. Like, if your pipeline is built right, the lawyers don't even need to be involved.
That's spot on. Compliance is fundamentally a data problem. I mean, think about the right to be forgotten.
Right. If a user says, delete my data.
If you can't locate exactly where a specific piece of customer data lives across your entire global system, you physically can't securely delete it. You can't protect it.
Because it's duplicated in 10 different spreadsheets and servers.
Exactly. Compliance has to be built into the infrastructure itself through strict access controls and automated audit trails.
So when organizations finally hit that wall and go to the market looking for help, they're typically hunting for core services. We're talking about data architecture design, pipeline automation, and cloud migration.
And real-time processing, which is huge right now.
Yeah, real-time processing feels absolutely crucial for industries like finance or logistics. I mean, if you're managing a global fleet of delivery trucks and your data is even 5 minutes delayed, a truck misses its highway exit, and that delay cascades.
Oh, a 5-minute delay in logistics is a lifetime.
Exactly. It ends up costing thousands of dollars in fuel and missed delivery windows just from one bad data ping.
If we connect all these services to the bigger picture, the real so what for the business leader listening right now comes down to one single metric: speed to insight.
Speed to insight. I like that.
When a business dashboard takes 6 hours to load, or the data is a day old by the time it actually reaches the executive team. Decision-making completely paralyzes.
You're constantly reacting to yesterday's news.
Precisely. Efficient, automated pipelines cut that lag entirely. Companies that get faster access to accurate data make faster, better decisions. And that capability compounds over time, creating a massive, often insurmountable competitive advantage.
We know what needs to be built, and we know why it's so critical. But handing off your most sensitive proprietary data to an outside partner is terrifying for most executives.
It's a huge leap of faith.
Let's map out the ecosystem of who is actually building these modern pipelines, because the landscape is incredibly diverse, and frankly, it's easy to get lost.
It is a crowded market, but we can categorize it to make sense of the noise. Let's start with the foundational platforms.
Yeah.
These aren't the consulting partners. These are the core technologies powering the modern infrastructure.
Right, the tools themselves.
Exactly. You have Databricks, which is completely reshaping modern architecture with its unified lakehouse concept.
Wait, I want to pause there. What makes a lakehouse different from the data lakes and data warehouses we've been hearing about for the last decade?
It's a great distinction. Historically, companies had a data lake for cheap storage of raw, unstructured data, and a separate data warehouse for highly structured, analyzed data.
So you had to move things back and forth.
Yeah, and moving data between the two was slow, clunky, and expensive. Databricks essentially merged them. A lakehouse gives you the vast, cheap storage of a lake, but with the high-performance querying power of a warehouse.
Oh, wow. So best of both worlds.
Exactly. It handles both batch processing and streaming workloads beautifully, largely because it's built on Apache Spark, which is an open-source engine designed for incredibly fast, large-scale data processing.
That makes a lot of sense. You're removing a massive bottleneck. And alongside Databricks, we also see Snowflake everywhere now.
Yes, Snowflake offers incredibly powerful cloud-agnostic analytics, meaning you can run Snowflake natively across AWS, Azure, and Google Cloud without having to physically move your underlying data.
That kind of flexibility must be huge for massive enterprises.
Oh, it enables seamless, secure data sharing across completely different environments. And we can't overlook Informatica either. They're the veteran in data integration and governance.
Right, the gold standard for compliance.
Yeah, their intelligent data management cloud is highly trusted,
Yeah.
especially in heavily regulated industries that just need airtight governance.
Okay, so those are the platforms, the tools. Now let's look at the builders. On one end of the spectrum, you have the global giants. These are massive IT outsourcing firms like Accenture, TCS, or Infosys.
The heavyweights.
Right, they're built for massive scale. If you're a Fortune 50 company doing a 5-year, multi-billion-dollar global transformation spanning 40 countries, these are the firms you call. They have proprietary frameworks and tens of thousands of engineers.
But while those giants handle the massive, sprawling rollouts, there's an entirely different category on the opposite end, the agile specialists.
The surgical teams, basically.
Exactly. These are niche players offering highly targeted speed and expertise for very specific problems. For instance, a firm like VD Core comes armed with a suite of proprietary in-house connectors.
What does that mean for the client?
Well, if you're an e-commerce brand, they can instantly extract your data from sources like Shopify and QuickBooks in a matter of minutes, drastically cutting down the integration time that might take a larger firm weeks to custom build.
Or a company like Uvix Software, providing senior Python staff augmentation without restrictive vendor lock-in, which, lets companies scale their internal engineering capacity up or down instantly.
Exactly. Very targeted solutions.
So you have the massive scale of the global giants on one hand, and the hyper-specific targeted speed of the agile specialists on the other. But there's a really interesting sweet spot right in the middle for mid-market and enterprise agility.
The Goldilocks zone.
Yes, for companies that need enterprise-grade reliability, but just can't afford to get bogged down in years of red tape. And this brings the conversation to our home turf. Here is how we at Kanerika approach this exact challenge.
Yeah, we at Kanerika operate precisely in that strategic middle ground. And our credentials speak directly to that balance. We're a Microsoft Solutions Partner for Data and AI, and a certified Microsoft Fabric featured partner.
We're playing right in the sandbox with the best tech.
Exactly. We specialize deeply in the exact modern stack we just discussed. Microsoft Fabric, Databricks, and Snowflake. But what really stands out in this industry isn't just the tech stack, it's delivery consistency.
Right, the follow-through.
We maintain a 98% client retention rate across more than 100 enterprise clients over the last 10 years. In the consulting world, keeping 98% of your clients for a decade is practically unheard of.
It means the pipelines actually work long after the initial deployment. And what we're really excited about is how we integrate innovation directly into the workflow. We deploy our own named AI agents to accelerate massive data
It
processes.
completely changes the game.
It does. We have DocGPT for instant document intelligence and an agent named Carl who actively analyzes complex data to deliver rapid, real-time insights to the business. But the true game changer, the engine behind a lot of this speed, is our proprietary migration accelerator, FLIP.
Oh, Flip is incredible.
When businesses are dreading the move from legacy systems to modern cloud architectures, FLIP cuts the migration effort by 50 to 60%. We're talking about turning grueling, multi-month migration projects into highly efficient 2 to 8 week sprints.
To give you a concrete example of how this impacts the bottom line, we at Kanerika recently helped a major manufacturing firm migrate from Azure Data Factory over to Microsoft Fabric using the Flip platform.
And what state were they in before we stepped in?
Their operations were completely failing. I mean, their data pipelines were incredibly slow, their Parquet conversion steps were consistently breaking, and their cloud infrastructure costs were soaring with almost zero return on investment.
Hold on, for those of us who might not be deep in the weeds of data formatting, what exactly is Parquet and why does converting it break a company's pipelines?
It's a great question. So most people are familiar with CSV files or Excel spreadsheets, right?
Sure, standard rows and columns.
Right, they store data in rows. And that's fine for small data sets, but when you're dealing with billions of records, searching row by row is incredibly slow and expensive.
It would crash any standard system.
Exactly. So Parquet is a specialized file format that stores data in columns instead of rows, which makes running analytics exponentially faster and cheaper.
Oh, I see.
But converting massive amounts of messy, raw data into that clean Parquet format requires a lot of computing power and perfect logic. If there's an error in the raw data, like a corrupted timestamp, the conversion breaks, the pipeline halts, and your dashboard goes blank.
Which is a nightmare scenario for an operations team trying to track global manufacturing.
Exactly. So post-migration with Flip, the transformation for this client was night and day. Because we automated the transition, they saw an 80% faster time to business insights.
80% faster, that's massive.
We delivered a 50% improvement in total pipeline efficiency, meaning those conversion breaks basically disappeared. Furthermore, we standardized their data governance globally by integrating Microsoft Purview from day one, so their compliance was locked in automatically.
You know, I used to look at the Flip platform like a white glove moving company, packing up your old house and moving it perfectly to a new one. But honestly, that doesn't really capture the complexity.
No, it's a bit more complicated than boxes.
It's less like moving boxes and more like translating a massive library of books from French to English while the library is still completely open and people are actively checking books out. You have to migrate and translate the data without disrupting the ongoing business. That's the real-time risk that Flip mitigates.
That's a much more accurate way to look at it. You're mitigating the absolute highest risk part of data modernization, the transition itself. If you get the transition wrong, you lose data and you lose trust.
So we've explored what good architecture looks like and how we approach it. How should our listeners evaluate these traits when choosing their own champion in the market? Because clearly picking the wrong partner is an extremely expensive mistake.
There's a very specific blueprint for evaluating a data engineering partner. You really need to scrutinize 5 critical criteria.
Okay, let's hear them.
First, industry expertise. Second, technology stack compatibility. They need to be native experts in the specific platforms you intend to use, not just learning on the job.
Nobody wants to pay a consultant to learn.
Exactly. Third, high-level cloud certifications to prove that expertise. Fourth, a verifiable portfolio of proven success stories. And fifth, scalable support models that ensure long-term maintenance after the initial build is complete. You don't want a partner who builds a complex system and then just disappears.
I'm going to challenge one of those criteria, actually.
Okay, which one?
If a consulting firm comes to the table with top-tier cloud certifications, let's say they're highly certified in Azure, AWS, Databricks, all of it, does industry expertise really matter that much? I mean, code is code, and a pipeline is a pipeline, right?
Yeah, that raises a vital point, but the answer is absolutely yes. Industry expertise matters immensely.
Really? Even with the best tech?
Oh yeah. The underlying technology might be identical, but the business context is everything. Think about building a data pipeline for a major healthcare provider versus a global retail chain.
Okay, quite different worlds.
In healthcare, you are dealing with strict IPO compliance, massive amounts of unstructured patient records, and incredibly sensitive privacy protocols. Security and auditability are your primary drivers.
Right, the stakes are incredibly high.
Now look at retail. In retail, you're dealing with real-time inventory streaming, supply chain logistics, and rapid consumer transaction data. Speed and volume are your primary drivers there.
Ah, I see.
The cloud environment might be Microsoft Azure in both cases, but the business logic required to structure that data is worlds apart. If your partner doesn't intimately understand your industry's specific KPIs and regulatory laws, the pipeline will ultimately fail the business, no matter how elegant the code itself is.
That makes total sense. You can build a beautiful pipeline, but if it doesn't actually measure what the business needs to survive, it's totally useless. The architecture absolutely has to reflect the reality of the business.
Perfectly said.
So, what does this all mean for you listening right now? If we synthesize everything we've covered today, the core message is clear. Data engineering is the ultimate dividing line between businesses that merely hoard data and businesses that actually use it to win their market.
It's the difference between potential energy and kinetic energy.
Exactly. Gathering information is easy. Anyone can do that. Organizing it into an automated, reliable, and compliant engine is the true challenge of the modern enterprise. That's why we at Kanerika focus so heavily on zero-code data ops with our FLIP platform and KanGovern, ensuring that compliance, reliability, and speed are built into every single deployment from the very beginning. You simply shouldn't have to choose between moving fast and moving securely.
And I'll leave you with this final provocative thought. Everyone in the business world right now is completely obsessed with the intelligence of AI models.
It's all anyone talks about.
We focus on the parameters, the logic, and the reasoning capabilities of the latest AI. But if artificial intelligence is entirely dependent on the data feeding it, are we focusing way too much on the AI brain and not nearly enough on the data supply chains keeping it alive? If you're experiencing AI hallucinations, it's often not the model's fault, it's the data's fault. An AI model fed by broken, delayed, or messy data is a massive liability, not an asset.
A brilliant point to end on. You simply cannot build a skyscraper on a cracked foundation, and you can't build an AI strategy on a digital landfill. Thank you for joining us for this deep dive. We highly encourage you to take a hard look at the data pipelines running beneath your own business today. Are they built to power your future, or are they quietly holding you back? Until next time, keep innovating.